Hey guys, so chapter 3, numerically summarizing the data. So chapter 1, we learned how to collect data. Chapter 2, we learned how to organize the data. So now chapter 3 is going to be about actually finding what the data is useful for. So finding like average, finding the spread of the data and all that. So here, when we look at a distribution of data, we should consider 3 characteristics of the distribution: shape, center, and spread. Of the distribution, the shape. So we talked about shape the very last section that we went over. So either a uniform distribution, a skewed left distribution, skewed right distribution, or a uniform distribution. So all of that is going to tell us a lot about the data. The center of the data, what is our average like data value? So how could we see the difference in that? And spread, so how far does it vary? Are we talking about length of a grain of rice, or are we talking about distances to, I don't know, traveling distances? So that's what the spread is talking about. Center and spread are numerical summaries of data. The center of the data set is commonly called the average. Once these 3 characteristics of the distribution are known, we can analyze the data for interesting features, including unusual data values called outliers. So there's a lot of different things. Once we find these numbers out, there's a lot of different things that we could do with that. And this section specifically is going to talk about the measures of central tendencies. So the measure of a central tendency numerically describes the average or typical data value. 3 most widely used measures of central tendency are mean, median, and mode. In the media newspapers, blogs, so on. So average usually refers to the mean, but be aware some reporters use average to refer to the median or mode. So that could change drastically. These 3 measures of central tendency can give very different results. So we have to be really, really careful with that stuff. Objective 1. All right, so the arithmetic mean. So arithmetic mean of a variable is computed by adding all of the values of the variable in the data set and then dividing by the number of observations in that data set. The population arithmetic mean, pronounced mu, so we have this little Greek letter mu, is computed using all individuals in the population. So this is known as our population mean. The population mean is a parameter. So going back to chapter 1, population parameters, sample statistic. Next is the sample arithmetic mean. So this one is going to be denoted by X bar, so X with a little bar above it. And this is pronounced X bar. And this is computed using the sample data. So where population arithmetic mean is looking at the population data, sample arithmetic mean is looking at the sample data. And the sample mean is a statistic. So population parameters, sample statistic, just remember that stuff. While other types of mean exist, the arithmetic mean is generally referred to as the mean. So arithmetic mean for the rest of the semester, we're just going to say population mean mu or sample mean X bar. Arithmetic is just referring to how we acquired this information, and we use it using arithmetic. So we're adding everything together, dividing and dividing. All right, so now looking at this here, we have mu. So if x1, x2, all the way up to x sub capital N are the n observations of a variable from a population, then the population mu is going to be the sum of all of these variables divided by the size of the population. This here is a little bit of new notation. So this is called summation. So when we see this, it means that we're going to add everything together. So summation, the Greek letter here is sigma. So this is a capital sigma. Just like we have a capital A, lowercase a, we have capital letters in the Greek alphabet as well. So capital sigma versus a lowercase sigma, we'll see that in the next section. And we're dividing this by a capital N. So remember, capital N is always going to denote the size of the population, Little n is always going to denote the size of the sample, just like we have right here. So little n is the size of the sample. And here, if we have x1, x2, all the way up to x of little n, there are n observations of a variable from a population, then the sample mean x bar is going to be the sum of all of those values divided by the number of observations. So again, the sum of all of the values in the sample size divided by the number of variables in the sample size. All right, so now looking at this data right here. So the data in table 1 represents the first exam score of 10 students enrolled in introductory statistics. So we're going to treat the 10 students as a population. So remember, we're looking at just this classroom. So because we already noted this as the classroom, like the entire classroom, this is going to be the population. So A, compute the population mean. B, find a simple random sample of size 4 students. And C, compute the sample mean of the sample found in part B. So let's go ahead and get started with that. We're first going to take a picture of the data. Perfect. And we're going to come right over here to Excel. And since we're slowly but surely becoming experts on this, we're going to get the data from the picture. And last screenshot I took. And from here, the most important part is going to be that the data is correct. We really don't care whether the names are correct at this moment. So data looks good, insert data. And now that we have that, we could start our findings. So remember, here we're looking for population mean. So population mean is going to be the sum of all the x's divided by the population size. So let's find those two different parts, the sum of the x's. So sum of the x's, we're going to look for the size of the population 2. And that's ultimately going to get us the sample mean. All right, so now the sum of all of the values, what we're going to do is add all of these values up and see what we end up getting. So here we're going to hit equals sum. So the sum of all of these values here. And now that we have that number, n is the number of data values that we have. So you could see that these are numbered off 1 through 10. So there's 10 students here. So that tells us that n is equal to 10. And lastly, to find the mean. So the mean or the population mean here is going to be the sum of all the values divided by the number. And since we have those all nice and pretty for us, that's all we have to do. So now answering the very first question, compute the population mean. The population mean in this case is 79, which is what we got right over here. So 79. So B, find a simple random sample of size n equals 4. So there's a bunch of different ways that we could do this. We talked about this in the previous chapter. So what we could do here is find a simple random number generator. So here, Excel actually has a random number generator. So we could just say rand between. So our lowest data value is going to be 1 since they already have them numbered off for us. And the top data value is going to be 10. So we could run this a total of 4 times because they wanted a sample size of 4. So we're going to run this a total of 4 times. And yep, we don't have any numbers that are alike. So from here, we could go ahead and match everything up together. So person number 7 is Joel. And I'm not sure why it keeps doing that. All right, where these numbers keep changing. Okay, well, since the numbers keep changing, I guess I'll go down here. So person number 6 is Dave. And I'm not sure what keeps happening. Okay, so we'll just write these numbers down. So we're looking at the random numbers 6, 3, 4, and 9. And let's just delete all of these. All right, so person number 6 is Dave. Person number 3 is Bailal. Number 4 is Pam, and number 9 is Justine. And Dave scored a 68. Bilal scored a 90. Pam scored a 71. And Justine scored a 94. So now with this here, we would say that this is our sample. So let me write that down. So this here, all that data there is our sample of size n equals 4. So here we could do the exact same thing here. So looking for the sum of all of these numbers. So the sum of the values of x there. This time we're going to use a little n because it's our sample size. And lastly, we're going to find the population mean. So I know this isn't exactly an x bar, but it's the closest thing to an x bar that I have here. So it's going to work for us for the semester at least. All right, so the sum of the x's is going to be equal to the sum of these values. So sum of these values here. So 323. And we have 1, 2, 3, 4. We have 4 data values there. So now x bar is going to be the quotient of those two. So 323 divided by 4. And there we go. This is our sample size right here. And there we go. We actually found everything that we need to find here. Let me clear this. Perfect. So now we have our mean, which is the mean of the entire population versus the mean of our sample size. And notice that the numbers are really close to each other. Here we have 79, over here we have 80.75. So on average, it's going to be a little bit smaller, a little bit larger than our actual population. Very rarely are the population mean and sample mean going to be exactly the same. So there we go. Let's see if we missed anything. All right, so the sum of the first 10 values, they got 790, which is what we got. Dividing this by 10 because we had 10 different values here. And they ended up with the mean of population mean of 79. Although it was not necessary in this problem, we will agree to round the mean to 1 or more decimal places than in the raw data. Here they use the calculator to find a random number generator. And they use those 3 values. So they added those numbers together. So their population, or I'm sorry, their sample mean is going to be different than our sample mean, just because they ended up with a different sample than we did. So notice they ended up with sample of 5, 10, 2, and 6. We didn't. We ended up with a sample of 6, 3, 4, and 9. So their sample is different than us, which is going to make their sample mean different than our sample mean, which it ended up happening right there. All right, it helps to think of the mean of the data set as the center of gravity. So in other words, it means that the value is such that the histogram of the data is perfectly balanced with equal weight on each side of the mean. So the figure shows this histogram of the data in table 1 with the mean labeled at the histogram. So here they used classes again. So from 60 to 65, they only had one person. From 65 to 70, again, they only had one person. From 70 to 75, they had two people, so on and so forth until they looked at the entire data set here. And they're able to balance everything perfectly right here at the mean of 79. So there's enough weight on this side than there is on this side over here. All right, so determine the mean of the variable from raw data. All right, so, or median, not mean, so median. So the median of a variable is the value that lies in the middle of the data set when arranged in ascending order. So we use capital M to represent the median. So steps in finding the median of a data set. So step 1, arrange the data in ascending order. Step 2, determine the number of observations N. Step 3, determine the number of observations in the middle of the data set. If the number of observations is odd, then the median is going to be the exact value in the middle of the data set. So that is if the median is going to be the observation that lies in the n plus 1 divided by 2 position. So we're always going to add 1 so that way we could get exactly to the middle. However, if the number of observations is even, then the median is going to be the mean of the two middle observations in the data set. That is, that the median is going to be the observations that lie in the n plus or n divided by 2 plus 1 and n divided by 2 position. Sounds a little weird, but let's go ahead and get started. All right, so in the data table 2, or in the data table 2 represents a length in seconds of a random song released in the 1970s. Find the median length of songs. So we have all this data set right here. And remember, the very first thing that we have to do is put it in ascending order. So from the smallest data value up to the largest data value. So we're just going to organize that part right now. All right, so the length of the song, the smallest song I see is going to be 179. So we'll write down 179 right here. The next one, there's number 100s. So 200, next one is going to be 201. And 201, do we have 202? We have 208, 206, 206, 208. Now tens, we have 217. And that's it. 20s, 222. 30s, no. 40s, we have 240. 50s, we have 257. And the last one, 284. And we'll write all the numbers down here. Let's erase. All right, so now that we have that actually taken care of, I just rewrote it. I was having some technical difficulties. All right, so now that we have that, we could identify what these numbers are. Okay, so this one here is going to be the first number that we wrote down, the second, third, fourth, fifth, sixth, seventh, eighth, and ninth. So since we have an odd number of variables, we're able to just pick the middle number. So there's not going to be the average of two numbers here. So one way that we could do this is we could just cross this out. So we have one missing here, one missing here, then the two, the second one, the third one from the last. And breaking it all the way down, we see that the middle number is this 5. So that's an easy way of doing it. But what we're going to do is do it the way that the book recommended. So instead of this way, instead of that way, we could actually do it the way that the book recommended. All right, doing it the way that the book recommended, which is adding 1 to the sample size and figuring out what the middle number is there. So here the sample size is 9. So we have 9 plus 1 divided by 2. That's going to be 10 divided by 2, which is 5. So that's how we find out that this is a middle number here. So one, make sure that we put everything in order ahead of time, because what we normally do, what a lot of students do, is they just go off and do this part and say 5. They're like, okay, that's 1, 2, 3, 4, 5. So this is our median, when actually, in fact, that's not our median because this isn't organized yet. So once it's organized like it is here, then we're able to find out what the median is. So in this case, the median is 217. So the median song lyrics here is going to be 217. And let's erase everything. All right. So after organizing it, there's 9 observations, and we see that the middle number ends up being that one right there. So there should be like a little plus right here and a plus right here too. So adding those two, we see that the number ends up being 5. Perfect. And that's what they listed right here, the 5th data value. So notice that there are 4 observations on each side, just like we said earlier. So 1, 2, 3, 4 on this side, 1, 2, 3, 4 on this side. So there's always going to be the same number of observations on either side, even whenever we have an even number. All right, so next, find the median score of this data set. So again, what we're going to do is I'll show you how to do this on Excel to make it a little bit easier, because yeah, makes things just a little bit easier. And since we already have the data over here, we could just slide right on over here. Let's copy this data and take it to another page just so we're not confused with the original data right there. So now looking at this list right here, there's a couple of ways that we could sort this out. We could sort it out just by typing this in. So equals sort. We could sort by. We're looking at all this data here. That's the array that we're looking at. Sort by our values here. And it puts everything in ascending order. So smallest value in the beginning, largest value at the end. And now from here, we know that there's a sample size of 10. So here we have n equal to 10. And n equals 10. All right, cool. So it being an even number, we know that we're going to have to take the average of the 2 middle numbers. But what are the 2 middle numbers? So the first middle number is going to be 10 over 2, which is our 5th number. Then we're going to do the same thing, but add 1 to it. So that gives us 6. So the 2 middle numbers in this case are going to be 5 and 6. So we can number these off on the side. 8, 9, 10. And now from here, we see that the two middle numbers again are going to be those two. I'm just going to highlight it using Excel so we could see it a little bit better. So 5 and 6, those two are our highlighted ones. Those are our two middle numbers. And from here, we're going to take the average of those two numbers. So just like we said earlier, there's going to be the same amount above than there is below. So we have 1, 2, 3, 4 above. And we also have 1, 2, 3, 4 below. So now we would say the median, or the capital M, is going to be equal to the sum of these two values. So let's put parentheses so that way we could take the sum of those two values. And we're going to divide it by 2. So again, finding the average of the two middle numbers. And there we go. So this ends up being the median for that data set, for this data set. So the middle value of this data set. And even though we don't have a middle value because we have an even number of numbers or even number of data sets, it's still considered the middle of the data set. And let's see if we miss anything. So arrange everything and is equal to 10. So we're looking at 5 and 6. Added those two together and divided it by 2. So notice that there are 5 exactly. So just like we said earlier, 5 observations to the left, 5 observations to the right. But I was counting just those middle two numbers. So we have 4 observations to the left, 4 observations to the right. So notice that 50% or half of the students scored less than 79.5, and the other 50% scored above 79.5. So that's how we're able to justify these answers here. All right, so use statistical software or a calculator to determine the population mean and median of the test scores. So here's where we're going to take this data and we are going to just input the data and see what we end up, or see what pops out the other side. So we have our original data set here. So remember, what we're going to look for is the mean and the average. I'm sorry, the mean and the median. So population mean, because it's the population here. And so population mean, and we're also looking for the population median. So for mean, an easy way to find that is just going to be equals average. And we take the data set. That's a command that we use here for Excel. And the only reason why we type average in, even though the word average does mean like median, mean, median, and mode, those are all different types of averages. It just so happens that here in Excel, they use the word average instead of mean. Next is our median. And for the median, it's going to be equal to median and median of the data set. Enter, and it entered it for us. So here it's just a little bit off. So the mean is 79, median is 79.5. So that means that the middle value is just a little bit above the actual mean here. And that's it. So one more time for population mean. So let's kind of go over, summarize what we've learned. So for population mean, the Excel command is going to be equal to average. And then the data set here. So we would just highlight the data set for X bar, because population mean and sample mean are both computed in a very similar manner. We are still using the same command, average. And then average of the data set. And lastly, for the median, it's just going to be median. And then you would put your data set in there too. Just highlight your data set. So those are the 3 things that we went over so far. And there should be a little bit more to add to this. So now explain what it means for a statistic to be resistant. All right, so Yolanda wants to know how much time she typically spends on her cell phone. She goes to her phone's web and records, or website and records, and records the call length for the random sample of 12 calls shown in table 3. Find the mean and median length of a cell phone call. Which measure of central tendency better describes the length of the typical phone call? All right, so let's take a snapshot of this. Over here to Excel. Insert data from table. One, two, three, 7, 4, 5, and it looks good to me. Whoa. All right, so now that we have this data set, again, what we're looking for is the mean and the median. So let's find those two. So mean and median. So remember, mean, we said equals average of this data set. And for median, it's equal to median of this data set. So 7 and 4. So the mean ends up being 7, the median ends up being 4. All right, so what would this be? So let's take a look at these values here. So 1 minute, 2 minute, and we have a random one that's 48 minutes long. The average here, it's not going to really justify average being the mean. So the mean is not really going to justify what an average phone call is, because we do have an outlier, something that's exaggeratedly larger than the rest of these here. So a better measure of her typical phone calls is going to be here in the median. And let's see what they say over here. So mean 7.25. And I'm not sure why they did it like this. Oh, all right, never mind. All right, so 7.25 and 7.5. I hate that it does that whenever we do the samples here. 7.25 and 3.5. And let's see. So the figure below shows what we created on the mini tab. We use Excel. And here we have a dot product. So remember dot product, not dot product, dot table, dot plot. So the dot plot is really clustered right here because we have majority of our phone calls here. That one random phone call that lasted 48 minutes ends up being right over here. So see how there's this huge gap? This is what we're going to call an outlier in the following sections. This isn't average. This is way above average. So this isn't representing what a normal phone call looks like. That just so happened to be part of the data set. So because of that, we're going to consider our median as our average for this data set. So which measure of central tendency do you think better describes the typical call length? So since only one phone call is longer than the mean is not a representative of the typical call length. So the median is a better measure of central tendency for this data set. And again, because the mean is affected by this one right over here. All right, so the numerical summary of a data set or of data is said to be resistant if extreme values, very large or very small values relative to the data are not affected by its sustainability or by its value substantially. So it is resistant if it does not affect the outcome. So let's see here, relation between mean, median, and distribution shape. So the mean, whenever we have a mean smaller than the median, then we're going to be skewed left because we have more data to the left side than we do the right side of the mean. When they're equal to each other or roughly equal to each other, then it's going to be symmetric. Whenever the mean's larger than the median, we're going to be skewed right because we end up with more data to the right of our data set. All right, next we look at this data table. So the data in table 5 represents the birth weights in pounds of 50 randomly sampled babies. Find the mean and the median birth weights. Describe the shape of the distribution. Which measure of central tendency better describes the typical birth weight? So first thing I'm going to do is take a snapshot of this so that way we don't have to write everything down. And we're going to take it right over here. Let's get a new sheet going. And data from table. And this is all very wrong, so I'll fix this off camera just so you guys aren't here watching me fix it. Okay, so that wasn't any prettier. I actually had to go back and enter everything all on my own. So the data from the picture doesn't always work, so we just have to kind of work with it. All right, so from here, what they wanted us to find was the mean and the median. So let's go ahead and find that. So here it's not going to be a population mean, or yeah, it's not going to be population mean because we're looking at birth weights, right? So we didn't, only having these data sets here is not going to account for the entire population. There's way more people in their entire population than just these couple of data sets here. So what we're going to do is find the mean and, or actually the sample mean and the median. And we're going to see what those tell us. All right, so here sample mean is going to be equal to the average. So average data set or average of this data set here. There we go. And now that we have that, let's find the median. So equal to median of this data set here. And it gives us these two. So these two are pretty similar, but if you kind of look at the rest of this, they're all relatively similar to those. So here we would actually say that this is resistant because it's not being affected by a huge number over here. All right, so here, since the mean is a little bit larger than the median, we would say that, let's see. Since the mean is greater than the median, this tells us that we have a right skewed, or let's just make sure. So the mean is greater than the median, mean greater than the median. So this is going to be right skewed. Right skewed by slightly though. And the last question that they have is which measure of central tendency best describes the birth weight? So now that we have all of this data, so we could go ahead and graph this data too. Actually, no. So while we can do the graph, so just highlighting the data doesn't really benefit us much because the data doesn't really look that great. So we could come over here mess with the bins. So instead of doing auto, we could do number of bins. Say 8, we could kind of see like a good place where the data would fall, but it doesn't really give us that great of a, like, it does look like it might be a little bit more right skewed because the majority of the data is here, but it's not a pretty picture. So let's just skip it. All right, so it does show that it's right skewed. And coming over here, so for part B, they actually graphed it and saw that it was very, very faintly bell-shaped, but we would still need a little bit more evidence than what we currently have with the data set. And because the mean and the median are so close in value, we could use the mean as a measure of central tendency. So the mean is always going to be better unless it's not the better option. So if we're looking at a couple of different things, or if we're looking at the mean and the median, mean, median, and mode, and the median looks a little bit cooler, or the median and mean are close to each other, we're always going to check. We're always going to use the mean. And lastly, determine the mode of a variable from raw data. The mode of a variable is the most frequent observation of the variable that occurs in the data set. The data set, or the set of data, can have no mode, one mode, or more than one mode. So we could say no mode, one mode, or multimodal. So if an observation occurs more than once, we can say that, or if no observation occurs more than once, we would say that the data have no mode. All right, so here the following data represents the number of O-ring failures in all space shuttle flights. All space shuttles, so this is going to be population. All space shuttle flights prior to the fatal flight of the space shuttle Columbia, which occurred back in '86. So looking at this, we had 0, 0, 0, a bunch of zeros, 1, 1, 1, 1, 2, and 3. So find the mode of O-ring. So here it might be a little bit weird. We might want to say that there's two modes, so the mode of 0 and also the mode of 1. But let's go ahead and count to see how many of these we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and 17. So we have 17 of them, or 0, not 17 zeros. And for the number 1, we have 1, 2, 3, 4. So even though we have multiple ones, 1 is definitely not the mode. So the mode here is going to be 0. So the mode is 0 because it occurs most frequently. So 17 times to be exact. The other one, or 1, just happened 4 times. So 17 times is greater than 4. So we would just say that it's 0. Now looking at this data set, find the mode of the exam scores data listed in table 1. So which here repeats. So visually we could see this. We could put it in numerical order if you wanted to, or you know what, yeah, let's go ahead and do that. So we could sort it out back on Excel if you wanted that too. But starting here, 70, 62. So it looks like 62 is the smallest one. Next is 68. That's the next smallest one. Any more 60s? No. 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, and then 80. No 80s, so we go to 82. And 84. 88, then 90, and 94. So now that we have these all in order, we do not have any that repeat. So there aren't any other 62s, there aren't any other 68s, and we're going all the way down the line. So here we would just say that there is no mode. So no mode because there aren't any data that repeat here. So since each data value occurs only once, there is no mode. And now we could talk about the multi-modes. So a data set can have two modes. In this case, we say that the data are bimodal. So bi as in bicycle, two different modes, so bimodal. So if a data set has three or more data values that occur with the highest frequency, the data set is multimodal. So multimodal because there's multiple modes. So the mode is usually not reported for multimodal data because it is not a representation, or it's not a representative of the typical data value. So if it has a bunch of variables that are exactly the same, there really is nothing to say about that. So we wouldn't report that. It's only interesting when there's like two modes that are the same, or the one mode. So with one mode, it would look like A. With multi-modes, we would see two different little hills here. And that's just showing that there's two places where majority of the data lies. The average on this one is still going to be somewhere right here in the middle. All right, clear this. So the data in table 6 represents the location of injuries that required rehabilitation by a physical therapist. Determine the mode location of injury. So this one here, what we could do is either put it on Excel and have Excel do all the work for us, or we could just write these down in a similar way that we did in chapter 2. So here, starting with hip. Hip, we have 1, 2. Hip, 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 and it looks like we don't have any more hip. And then knee. We have 1, 2, 3, 4, 5. 2, 3, 4, 5. Next is back. We have 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3. And one more. That's back. Next is shoulder. We have 1, 2. 1, 2. That's it for shoulder. Wrist. We have 1, 2. Elbow. Let's see, 1. And that's it for elbow. Hand. Just 1, 2. Groin. Just 1. Neck. 1. And it looks like that's it. All right, so looking at these, the one that occurs the most, we have 2 here, 5 there, 12 here, 4, 2, 1, 2, 1, and 1. So here, the one that occurs the most is going to be back with 12. So even though there's multiple of the other ones, back has the most, and therefore it's the mode. So the location of injury is back, or the mode location of injury is back with 12 instances. And here's a little summary of everything that we went over. And there we go. If you guys have any questions, you guys could send me an email, just ask. If Not, then good luck on your homework. Bye.